Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and we're talking about reciprocal graphs. Let's start by thinking about the word reciprocal. We've seen it before. Can you link back to prior knowledge and state the reciprocal of the following four numbers here? Pause the video and have a think. Now, if you're not sure of reciprocal, you really need to go back to your building blocks. Reciprocal of a number means 1 divided by that number. Okay, so the reciprocal of 4 is 1 divided by 4. The reciprocal of 7 is 1 divided by 7. The reciprocal of 0.2 is 1 divided by 0.2, which we can work out as 5. And the reciprocal of 4/5 is 1 divided by 4/5. Dividing by a fraction is the same as multiplying by its reciprocal. That gives us the answer 5/4. When you do 1 divided by a fraction, it just flips the fraction. So my question to you is, what is the reciprocal of x? Well, if x is your original number, an unknown number, its reciprocal is 1/x. So we're going to be in this particular video drawing graphs like y is equal to 1/x, and they are called reciprocal graphs. When we always start learning about a particular graph, we start with a table of values, see if we can start spotting some patterns, and we may be able to do more detailed algebra afterwards, but in this video we're just going to use the table of values. So let's start. Pause the video and copy and complete the table and plot the graph y is 1/x. Okay, I'm going to do this, but I'm going to do it quickly. You may want to slow me down. I'm not going to talk through how to do this. Okay, I have completed the table of values other than one particular value. Now, 1 divided by 0 caused me a lot of problems, and we've talked about before how you're not allowed to divide by 0. When you do that on your calculator, it says undefined, and that's going to be a key point on our graph, some feature of our graph we need to talk about. Anyway, now I'm going to plot the other sets of coordinates apart from this one, and we'll see what type of shape we get. Again, I'm just going to go through this quickly without talking. You may want to pause and slow me down as it goes through. Okay, so we're going to try as best we can as to put a curve going through these. They would look something like this. It's hard to draw, so it looks something like this. Okay, and there we go. We have a rough graph of y equals 1/x. It looks something like that. And it's got some key features. The first thing is, when x is 0, the graph shoots off to positive infinity and negative infinity there. And this is a line which we're going to come back to later. That's going to be called an asymptote. And in fact, it's going to be called a vertical asymptote. And what that means is that the graph goes off towards this point, but it's never going to touch it. It's never going to touch this line here. There is also a horizontal asymptote, which is going to be here. As you can see, x will shoot off towards infinity here, and 1 divided by a massive number, it's near 0, but it's never going to get to 0. Similarly, x will shoot off towards negative infinity here, and 1 divided by, let's say, negative a million, well, it's negative 0.0000001 or something like that. It's very close to 0, but it never gets to 0. And our reciprocal graph always looks something like this. Now let's have a go at another similar one. Let's draw the graph y is negative 1/x. Pause the video, copy and complete the table, and try and draw the graph. Again, I'm going through it really quickly here. You may want to slow me down. I'm not going to explain my substitution. And let's give it our best shot at trying to plot these. Again, hopefully you notice we've got a problem by dividing by 0. That's going to be undefined. We think that's going to be a vertical asymptote, don't we? Let's have a see if that turns out to what we think. So I'm going to go through these quickly. You may want to slow me down. And again, we're going to have some asymptotes. That there is our vertical asymptote. Our graph is tending towards that line, although it never reaches there. So that there is our vertical asymptote, which is actually the line x is equal to 0. And we also have a horizontal asymptote, which is going to be this, which is actually the line y is equal to 0. And if we compare the two graphs, one is just a reflection of the other in the y-axis. You can just see that they are reflections of each other in the y-axis, okay? And let's draw another one. Pause the video, copy and complete the table, and try and draw the graph. Okay, I'm just going to show you the answers for this. You have to be good enough at substitution for this. So when I substituted those values in, I got the following. And then I tried to plot the pairs of coordinates against each other, and I got a graph that looked a bit like this. And it seemed to me that the graph had a vertical asymptote of x is -3, and it had a horizontal asymptote again of y is equal to 0. Now I just want to point out why x is -3 might have been the vertical asymptote here. If you think about it, if I put -3 into my original function, I have 1 divided by 0, and I'm not allowed to divide by 0, and that tends to be where my vertical asymptote is. My horizontal asymptote is where the graph is tailing off to as x goes massive. As x goes massive, x is going to y is going to tend to 0, and as x goes very negative along this side, x again was tending to sort of -0, small numbers, very tiny numbers, negative numbers that are close to 0. Okay, so that's the type of graph we're going to get. Let's have a go at another one. Pause the video, copy and complete the table, substitute in for the table of values, and try and draw that graph there. Okay, if you did that, you would have got the following table of values, and plotting them, I got myself a graph that looks something like this. And I've also labelled in what I thought were the vertical asymptotes and the horizontal asymptotes. Now, just to point out why the vertical asymptote is as it is, when x was 0, the graph was undefined. I'm not allowed to divide by 0, and that's where I said my vertical asymptotes are. So the line x is equal to 0 is my vertical asymptote. Now my horizontal asymptote is now y is 5. In all previous ones it's been the y equals 0 line, or the x-axis as we call it. Now why is that the case here? Well, the way to think of it is, as x was becoming a massive number, as x became 10, you can see that these numbers are starting to go towards 5. If x was 1,000,000 or something, this would have been a very close number to 5, but just slightly below 5. So the graph is going up towards the line y is 5, but it's always slightly underneath it. On the other side of things, when x was very negative, -10, we had ourselves 5.1. It was tending to 5, but from numbers bigger than 5. If we went to x's -1,000,000, let's say, it would have been a number just near 5, but just slightly bigger than 5. So that's why our horizontal asymptote is y is equal to 5. Let's finish by looking at the graphs we've drawn and see if we can draw out some similarities from their general shapes. So here are the graphs that we've drawn in this particular video. I need you to be able to recognize the graph y is 1 over x. You probably shouldn't have to draw a table of values. I want you to be able to draw it like that. And y is -1 over x. It's very like this one, other than it's a reflection of the other one in the y-axis. So I need you to be able to draw these two. Now in the next video we're going to go on to see if we can draw these without drawing the table of values here. The only thing I want you to notice at this point is that this is a positive x, 1 over x graph. So it's looking very like this one, other than it seems to have been shifted that way by 3. Alright, by 3 units, and its asymptote isn't at x is equal to 0, it's at x is equal to -3, but it's like that one. And this one, again, we've got the -1 over x on the go like we've got above. Alright, so it looks like the -1 over x graph. It has a very similar shape to that, other than to say one thing. It looks like this graph here has been shifted up. And it's been shifted up 5 units. If we shifted both these sides of the curve up 5 units, we'd get this graph. And in this case, remember, the horizontal asymptote wasn't y is 0 anymore. It was y is equal to 5. Okay, so in the last video we're going to try and draw these in a more efficient way than using table of values. But from this video, if you just recognize the shape of reciprocal graphs, that would be great. Anyway, that's it for this video. Thanks loads for watching.